My brother moved into an older home and had concerns about the electrical system. The house had the original wiring from the 1960s, and he wasn't sure whether the outlets were properly wired, grounded, or safe. An electrician quoted him $400 just to do a whole house inspection. Before he paid, I gave him a $2 device that tests every outlet in minutes and reveals most wiring problems. He spent an afternoon checking every outlet in the house and found several with reversed polarity, 2 with no ground connection, and 1 that had an open neutral. He had an electrician come out to fix only the specific problems rather than paying for a full inspection. Total electrician visit, $150. Let me walk you through why outlet safety matters, why so many homes have hidden wiring issues, and the $2 device that reveals most problems. First, let's talk about outlet wiring. Every electrical outlet in your home has 3 connections: hot, the power wire; neutral, the return wire; and ground, the safety wire. These 3 wires work together to deliver power safely and provide protection against electrical faults. When outlets are wired correctly, everything works. Your devices get power, and safety features like GFCI protection and appliance ground pins work as designed. But when outlets have wiring faults, problems develop that can damage equipment, cause shocks, or start fires. Common wiring faults include reversed polarity, where hot and neutral are swapped. This doesn't affect most devices' operation, but compromises safety features and can cause shocks in certain conditions. Open ground, where the ground wire isn't connected. This means appliance ground pins don't actually ground anywhere, eliminating important safety protection. Open neutral, where the neutral isn't connected. This creates a situation where the outlet may appear to work but is actually dangerous. Open hot, where the outlet has no power. Reverse wired hot. And ground, a more dangerous fault where the ground wire is hot, potentially energizing appliance cases. These faults can exist for years without being obvious. Devices may work normally, lights may turn on, but safety features are compromised, and specific scenarios can result in shocks, damage, or fire. Professional electrical inspections catch these issues, but are expensive for routine checking. A full house inspection may run $200 to $500. The $2 device approach uses a standard outlet tester, a small device that plugs into any 3-prong outlet and immediately shows wiring status through 3 indicator lights. Different light patterns indicate different wiring conditions, and most faults are immediately identifiable. The devices cost $5 to $15 at hardware stores. For GFCI outlets specifically, upgraded testers add a GFCI test function that simulates a ground fault to verify the GFCI protection works. Here's the approach. Step 1. Get an outlet tester. Klein Tools, Southwire, Ideal, or other reputable brands make them. Look for one with clear indicator explanations printed on the device. A GFCI tester version costs a few dollars more. Step 2. Read the indicator chart. The 3 lights on the tester produce different patterns for different conditions. Common patterns include all 3 lights off, open hot, no power, 1 light on in specific positions, indicating open neutral or open ground, certain patterns indicating hot ground reverse or hot neutral reverse. The tester itself usually shows the chart. Step 3, test every outlet in the house. Plug the tester into each outlet. Note the light pattern. Record any faults. Include outlets in attics, garages, basements, and outdoor locations. Step 4, test GFCI outlets. These should trip when you press the test button on the outlet or the test function on the tester. A GFCI that doesn't trip is not providing its safety function. Step 5, test upstream of GFCI outlets. In some installations, one GFCI outlet protects other outlets downstream, wired in series. These downstream outlets may be regular receptacles, but get GFCI protection through the upstream device. Test them with the GFCI tester to verify protection exists. Step 6, identify patterns. Do multiple outlets in one room show the same issue? That suggests a shared wiring problem. Are issues consistent or random? Patterns help diagnose underlying causes. Step 7, address the issues. Simple fixes, you can DIY. Verify you're comfortable with basic electrical work first. For reversed polarity on a single outlet, turning off the breaker for that circuit, removing the outlet, and swapping the hot and neutral connections fixes the issue. Make sure to match the colors correctly per electrical code. For open ground, the issue is usually that the outlet isn't actually connected to a ground wire in the box. In houses built before grounding was universal, some outlets may never have had ground connections. GFCI outlets can be used to provide shock protection in ungrounded circuits, labeled appropriately. For GFCI outlets that don't trip, replacement is needed. A new GFCI is about $15 to $25 and straightforward to replace. For more complex issues like open neutral, unusual wiring patterns, or multiple faults, professional help is warranted. Don't work on things beyond your comfort level. Step 8, retest. After any repairs, confirm the fixes worked. Step 9. Document the house. Keep a record of each outlet and its condition. Mark the date. This provides reference for future testing and for any home inspection or sale. For specific scenarios, if you're buying a home, testing outlets yourself as part of due diligence is worthwhile. Issues found can be negotiated as part of the purchase or addressed before moving in. If you're selling a home, testing and fixing outlet issues beforehand prevents buyer concerns and supports the sale. If you have aluminum wiring, which was used in some homes in the 1960s and 70s, special attention to outlet connections is important. Aluminum wiring is generally safe when properly maintained, but requires specific outlet types rated for aluminum. If you have knob and tube wiring, which was common before about 1940, significant safety considerations apply. Consider professional assessment and modernization. If outlets are missing ground pins, 2-prong outlets, the circuits may not be grounded at all. These can be upgraded to GFCI outlets for safety protection, labeled appropriately. Full rewiring for grounding is a larger project. If you frequently trip breakers or GFCIs, there may be underlying issues worth investigating with a professional. For outdoor outlets specifically, GFCI protection is code in most areas. Outdoor outlets face water exposure and need reliable ground fault protection. For kitchens and bathrooms, GFCI protection is code for outlets near water. Verify protection in these locations specifically. For older homes that have never been updated electrically, consider a whole house assessment even after DIY checking. An electrician can identify larger infrastructure issues beyond individual outlets. A few honest notes. Outlet testers detect common wiring faults, but not all issues. They can miss some less common faults and don't test load capacity, wire condition inside walls, or breaker function. They're a starting point, not a complete assessment. For DIY electrical work, know your local codes. Some repairs require permits and inspections. Check before doing more than basic work. For questions about safety, consult a licensed electrician. Electrical work done incorrectly can cause fires, shocks, or code violations that affect insurance. For GFCI protection in older homes without proper grounding, code allows replacing 2-prong outlets with GFCI outlets. This provides shock protection even without a ground wire. Label them appropriately. For testing, don't assume that because things work, they're safe. Many wiring faults allow normal operation while compromising safety. The economic comparison, $5 to $15 for an outlet tester with GFCI function. Total, under $20 for thorough DIY outlet testing across an entire house versus $400 or more for a professional inspection. For targeted repairs of specific identified issues, professional help costs far less than a full inspection, plus repair. One more tip. Keep the outlet tester in a kitchen drawer or workshop. Use it whenever you move into a rental, when testing appliances that have been acting strangely, or when checking work done by electricians. For landlords, testing outlets before each tenant move-in and documenting results protects against liability claims and catches issues early. For parents of young children, GFCI outlets and tamper-resistant outlets, which require simultaneous pressure on both slots, dramatically reduce injury risk. Testing existing GFCIs and installing tamper-resistant outlets where kids might reach is worthwhile. And for anyone who wants to understand their home's basic systems, electrical testing teaches a lot in an afternoon. The knowledge helps with maintenance decisions going forward. If you've moved into a new home, grab an outlet tester for $15 and spend an hour checking every outlet. Any faults found inform specific targeted repairs rather than expensive whole house assessments. Outlet safety is checkable and fixable. The tools are inexpensive, the skills are learnable, and the results protect you and your home for a few dollars and a bit of time.